Hi guys, and welcome to Learn Extra Live Maths Lit. And as you can see, it's Indy and Haley taking you grade 11s for today's session.
Absolutely.
How are you, Haley?
Well, how
I
you
know
doing?
we've just done a show together, but now it's grade
we got
11. and
Hopefully
now
new people
Exactly. And hopefully the grade 12s have been tuning in all the time because they like to learn more and learn extra
absolutely,
all the time.
Yeah.
So what are we going through in today's lesson?
We're going to be doing data handling. I believe like last week, Peter did some central tendencies with them, so I'm going to carry on and doing a little bit of different representations and actually looking forward to being with the grade 11s for a change.
Yeah, no, the grade 11s are cool. I love the
Absolutely.
grade 10s, 11s, and 12s. But
me too.
the grade 11s are a special bunch. Do you want to take
I will, thanks.
take a spot? Okay, guys, you know the drill. Chat to me on facebook.com/learn extra. That's an XTRA. We are also on Twitter @Learn Extra, so you can get chatting to us. Let us know if there's anything that you don't understand. Send us your inspirational quotes. Let us know if you're struggling with anything. We are here to help you and help each other out as well. This is a great way to make friends and have an online study group. This community is not just for us guys, it's for you too. So what I'm going to do is I'm going to hand it over to Haley to start the lesson. Let's get learning.
Thanks, Indy. Okay, like I said, we're going to be doing data handling. We're going to be looking at some mixed exercises. And I know you did some central tendency last week, so we're going to start with that. And we're looking at question 1. Right. The table below contains prices of houses. I think I need a color. Prices of houses that were sold in 2 areas during the first 6 months of the year. The house prices have been arranged in ascending order. Always nice when they arrange them in order. But the first thing we need to do is to put them into order. So it's really nice. Right, and we're looking at 2 different areas. We've got hilltop and gardens. So each one of our houses, and we can see we've got a total of 15 houses sold in each area, and they give us our prices and of each house. Right, an estate agent gives you the following information about the house prices for gardens. The mean selling price is 424,200 Rand. So let's quickly go over what the mean means. So what have we done to calculate the mean? We took all our house prices in gardens, starting from our first one of 300. We added them all up, okay, and we then divided it by the total of 15. So it's what we talk in everyday language, we talk about an average. But in maths, we talk about a mean. So the mean selling price is 424. The median selling price is 440,000. That is the house that is right in the middle. And what do we mean by median? We've got as many houses selling for lower as we do selling for more. So our median selling price is 440 and the modal selling price is 320. That's the price that was sold the most. So modal's most, median's middle, mean is your average. So let's see what our question asks. Right. Explain which measure of central tendency, mean, median, or mode, provides the most accurate indication of the average house price in gardens. In your answer, you must also explain why the other measure of central tendencies are not appropriate. So, okay, first of all, let's decide which is the most appropriate. And the most appropriate, whenever they ask you, is in fact the median. So if they ask you this kind of question, it usually means that we've got huge outliers. So, and our outliers tend to skew our mean. So our median is great because it's got as many high, as many below. Whoops, can't write today. Below as above. Right, there are no outliers. The mean would be a problem, and let's go back to those numbers. And if we look at our numbers, right, starting at 300, then I've got 2 for 320, then I go up a little bit to 340, 360, so I'm all in the 300s, then I've got 400s, 500s, and finally my last number is 690,000, which was quite a bit bigger than the number just below that of 523. That is what we call an outlier. It is a number that is totally different from this kind of standard of what we've got. And that tends to skew the mean. It makes the mean a little bit higher than it should be. So that's the reason that that's no good, is mean we've got an outlier of, and we can even put it in, of 695,000. It was 695 Indy. And finally, what is not appropriate with the mode? Well, in actual fact, the mode was the highest number that was the same, and it was 320,000. There were only 2 houses sold for 320,000, but it is actually nearly the lowest. It's nearly the lowest as well. So always remember, if they ask you which central tendency, you need to be looking at the median. That is always your best one. Right, let's now look at Jacob. Jacob wants to sell his house in Gardens. He wants to sell it for 650,000. He places an advert online and claims that his amazing house is selling just above the average price of the area. As an interested buyer, what price should you offer? Now, if we go back to our averages, right, our averages, we've decided that our median was probably the best to look at. Well, 440,000 Rand. And he wants, what did he want? 600. He said just above average. Well, clearly 650 is way more than the 440. So your median was actually 440. In fact, there was only one house that was more than 650. So as a person interested in the house, what should you offer? I would say offer closer to the 440,000, and definitely not as close as 650. Also, when buying a house, do you always offer what they're asking? I think we always ask for more than we expect.
Exactly.
Okay.
Yeah.
But the fact is that it's way higher than the average. It's way higher than all the averages. So you're going to probably be spending too much on the house. So rather offer closer to the median. Now let's go to the next question, which says, calculate the range of the house prices for Hilltop and Gardens and explain what the difference between the ranges for the two areas tells you about the house prices in those areas. So let's start with Hilltop. I'm going to need you to remember numbers, Indy.
Okay, I'm
Okay,
here
so
for you.
Hilltop, we're going to go, it's from 150,000, and our highest was 580. And while you're remembering, remember Gardens is 300,000 to 690. Okay, we got all those numbers. So let's get a little bit more space here. Right, remember our range was our highest minus our lowest. So we're looking at the ranges, so we're looking for our high minus our lowest. Right, our highest for Hilltop was 6.
Was 6. Oh, the highest for the garden or the hilltop?
Hilltop.
Okay, so the
First
highest
ones I gave you.
580,000.
580,000.
Yeah.
580,000.
And
And the lowest,
was 150,000.
150,000. Okay, and I don't think we need a calculator for this, but if you do, take your calculator out. So we've got a calculator. So doing your calculator, 580,000 minus 150,000, and we get 430,000. So this is 430,000 Rand. That's our one range. And for Gardens, let's do Gardens. Okay, let's change our color so we don't get confused. What was Garden? It was 695.
The highest was 3,000.
3.
And then the lowest was 690. Unless
No, I think it was 695. Was it 690? Let's go back and check. Indy, we're not
You see, now this is why Peter
300 and 690. 690.
Oh, so 300.
300 and
So
690.
I said 3,000 and 690. I could have completely got everything wrong there, right?
Okay, so 690,000. Oops. What color were we in? 690,000. And the lowest, too many zeros, I think. And the lowest was 300,000. Am I right? 300. Okay, and what's our total here? Our total here is 390,000. So what does it tell us about the two? So now the question says, explain what the difference between the ranges for the two areas tells us about the house prices in those areas. Well, The lower, in actual fact, we've got very similar values. 390,000 and 430,000 is quite similar when we're dealing with such big numbers. But the lower that number would be, the lower the range would be, the closer the highest and your lowest are. The bigger the range, then the further out your big and your small numbers are. So that's basically what our range tells us. Okay. Let's move on to our next question. The average age for the top 15 female swimmers from London 2012 are given below. So what do we know about the ages of our swimmers? The mean age was 24.7 years. The modal age was 18 years, and the median age was 22 years. So those are quite interesting statistics. The mean average is higher than the other two averages. Can you explain how this is possible? Right, well, our modal just means that that's the most number, the number that the most. And our median means there's as many higher as lower. So if we're looking at 22 is our median. So we've got as many swimmers higher as we do lower. We know our modal age is 18, so we've got quite a few that are in this 18, and I'm guessing that we don't have very much younger than 18. But there are probably quite a lot of swimmers older than 22. Okay, so we're looking at the number here is equal to the number there. But this number here must be much higher than those 18, and possibly, I mean, how old do you think the youngest swimmer was? Probably about 16, 17?
Yeah.
Okay, so we're not going to as early, because remember, you've got to put it into context. So we're not going into just random girls. We're going into swimmers that have qualified for the Olympics in 2012. So my guess is you're not getting much younger than 18. But whenever we've got a big number, when we work out the average, the bigger numbers make our average higher as we go along. So these numbers that are bigger make it higher. And that's what you need to explain. So, and one of the ways you could do this is maybe just take your 18, and because that's just our mode, and let's now add somebody, and let's assume that they are 30 years old. Well, let's assume that there were swimmers who were 30. And if I just work out the average of those two, 18 plus 30, I'm going to get my calculator out. So if I've got 18 plus 30 divided by 2, I'll see that it brings my average up to 24. So my average for that was 24. And that is why we have a higher mean than we do a median. I hope that all makes sense.
It does. You want to know a quick fact?
Quick fact.
It has nothing to do, it kind of does. But I just Googled who's the youngest Olympic gold medalist, and the answer is the youngest individual Olympic gold medalist is Marjorie Gestring of the United States. She was 13 years old and 268 days when she won the gold medal at the 1936 Summer Olympics in Berlin, Germany.
Wow. And
There
what
you
was
go.
her sport? Do we know that?
She did. She won a gold for the 3-meter springboard diving competition.
Wow.
So swimming as well. Hey.
So I'm too
Back
old
in
to-
1936.
I'm too old and it's too late for me to start working this out.
Yeah, well, the bus
Okay.
is left for us. Oh.
But that's what you need to do. Make sense of the context of the question. So okay, so how would we explain it? Can you explain how this is possible? I would say, well, okay, I know that my lower half, my lower quartile, my lower half of my numbers does not start probably much lower than 16. My higher can go much higher than 22, and the bigger numbers actually skew the data and make it my average higher. I don't think I'm writing all that. I hope they got it. Right, question 3. Precious and Beauty are having an argument with some boys from their mathematical literacy class. The boys claim that boys are better at mathematical literacy than girls. I have this fight in my class constantly. They agree to compare the results of a test on equations. All of the numbers are given as percentages. So what we have is we have our girls' results. So let's read our results. We've got 80, 68, 75, and we can see, I'm not going to read them all out, we can see that these numbers are not in order. That's the first thing that jumps out at me. And if we count these, we've got 2, 4, 6, 8, 10, 12, 14, 16, 17 girls. So we've got 17 values. The boys, on the other hand, it tells us we've got our minimum, we've got our medium. So our minimum was 28, that's our lowest mark. Median was 68, and the maximum was 94. So the first question says calculate the median for the girls. Now I'm going to actually find a little bit of space. I need to find some space to calculate the median. No, let's do it here. Right, we need to put these into order. That's the first thing we're going to do. Now you can choose to place values in any way into order. I like to use a box and a stem and leaf diagram. So I look at my values and I see that my lowest value is 34. Okay, so I'm going to start with 3. So I'm going to do it on the side here. Okay, and I've got 4, 5, 6, 7, 8. I think 8 is our highest. Right, and then I go through these numbers in order, because I know you guys tend to look for the smallest and then look for the next one, and I like to go through them in a methodical order. So 80 is, I put it 8 there, we've got 68, I've got 75, 53, 64, 70, 94, okay, I do need a 9, I'm going to do it over here, 94, 68, 57, 61, and I just look at all the numbers, 61, another 61, 34, 86, 77, 77, and 73. And now from that, I can actually put them into order. So I've got 34, my next number is 53, 57, 61 3 times. Don't forget to add all of them. 64, 68. Now I'm going to start deleting a little bit of this. 68, I need twice. 70, 73, 75, 77, twice, and I'm going to carry on at the bottom. Right, so I've got 80, 86, and 90. What was that last number? 94. Just double check 2, 4, 6, 8, 10, 12, 14, 16, 17, that I've got the same 17 values. Okay, so now we can delete that. So any way you want to put these into order, that's fine, but as long as you get them into order. Now we're looking for the median number, so I've got 17 values. So my middle is, if I start 8 on one side and 8 on the other, my 9th value is going to be my median. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. I need to underline, and I'm going to just double check from the other side. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So quite clearly, my median is my 68. Right, now it says calculate the range for the girls. My range is my highest, which is 94 minus 34, and that gives me 60. And I want the range for the boys. Now my boys, I had 94 minus, their minimum was 28, and that gives me, I'm going to just check that on the calculator, 94 minus 28, we get 66. So the range is 66 for the boys. Right. Use your answers, give full reasoning as to which of the two groups did better in their test. Do you think we've got enough time for me to do this reasoning now?
I think so. Can we work through it? Oh, we've got 1:40. I want you to have your time, and I want you to explain this properly to the learners.
Okay.
So what we're going to do, guys, is we're going to take a break. If there is anything that you are struggling with understanding at the moment, please post on the page so we can run through it during the break. Hayley will come to me, and we'll have a look at all of your questions, and we'll go through them as soon as we get back, if there are, of course. So what we'll do is we'll see you now after the break. Hi guys, and welcome back to Maths Lit, grade 11s. I hope that you're all having an awesome time. Kumbudzo, he's posted the most amazing post. I'm going to reshare it now. See how many squares you can see in this post and let me know. Haley, I thought that there were a few, but Haley said that there are more than I think that there are. So have a look at that and see if you can work that through. So if you have any questions, post them onto the page. We will be answering them in the last 10 minutes of the show. No questions yet, so that's when I start thinking, okay, they're all understanding.
Absolutely. I hope they're all understanding. Okay, guys, so let's finish off this part of the question. So before we went to break, we were discussing the difference between the boys and the girls. And remember that I think it was the boys that said they did better. So we're now trying to decide. And for the boys, we didn't have all our stats. So let's first see what we had. Right. For the boys, we had our minimum, we had our median, and we had our max. For the girls, we had all our values. We worked out our two ranges, and we worked out the median for the girls. So in actual fact, what do we note about this? Okay. So let's look at our girls, and let's look at the boys. So let's kind of just analyze what we've got. Our median for the girls was 68. The median for the boys was also 68. So my median is not going to tell you much. So the child in the middle of the class, both boys and girls, got 68%. So we had as many girls lower and as many boys lower. Then we had our range. So the girls' range was 60 and the boys' range was 66. And let's just look at our highest mark. Our highest mark for the girls was 94 and for the boys was 94. So quite clearly, those are, let's get a different color. Those are exactly the same, not going to give me much. The boys are slightly higher, and here it's exactly the same. So what does this mean? Let's look at our low now. We know our girls' low was 34, and our boys' low was 28. So that is where, let's get a different color. This is where we have a difference. And this is where we have a difference. And this is the reason we have a difference. So, although it appears that they performed exactly the same, they got the same median, the boys' range is higher, which means that their variance is bigger. So their numbers have a bigger range, which means their lowest mark was lower, which is what we see here. So there is at least one boy who has done worse than the one girl who got our lowest mark of the girls. So can the boys say they performed better? I don't think so. Although in this particular case, their answers are very similar. So using your answer, give full reasoning for which of the two groups did better in the test. I would have gone with the girls, and they have a lower range. So their lowest was higher than the boys' lowest. Hey, let's move on to the next question. Right. We have a compound bar graph below showing the percentage of South African children from age 7 to 13 enrolled in primary school during 1996 and 2007. So before we go on to the question, I always like to read a table and understand a table fully. So what does our table give us? Gives us the percentage enrollment for the South African children in primary school. We've got our 2 years, 96 and 2007, and we've got different age groups. So we've got 7-year-olds, 8-year-olds, 9-year-olds, and we carry on with all the ages. What is important is it's a compound bar graph, so it gives us a comparison of 2006 to 2007 for the 7-year-olds, and then for the 8-year-olds and 9-year-olds, and it carries on like that. What's nice about this graph, and often you get this in a test, because these kind of graphs that are published, they like to give you exact values. So we could read that value off the graph, but in actual fact, they've given it to us there. So that we now know is perfectly is 94.8%. Remember, we were dealing with percentage. So that's percentage. So it gives us each one of these readings, which is really, really crucial. So you don't have to actually physically read yourself off the graph. Right, and the question says, use the graph above to answer the following questions. What percentage of the 10-year-olds was enrolled during 1996? So 1996 is yellow. We're looking at 10-year-olds. We're looking at that value here. And remember I said to you, we want to read that value, but it is given to us as 91.3%. So we don't have to do the reading. We can read it off the table, 91.3%. Okay, moving on to the next part of the question. Calculate the percentage increase in enrollment of 11-year-olds from 96 to 2007. So we're looking for a percentage increase. Now remember, as soon as we're looking for a percentage, we're going to times by 100. Now, what are we going to times by 100? So as soon as I see the word percentage, I know bells go off, I need to times by 100. We're going to take our new value, that's our 2007 value, minus our initial value, and divide that by our initial value. I like to tell my kids, I actually always tell them it's new minus old divided by old and times by 100. That's the formula I like to teach my kids, okay? And it's quite easy to remember. So we're going to be looking for those values. We need the 11-year-olds, and we need those enrollments. So we're looking at those values. 2007 was 96.3. So it's 96.3 minus our 2096 value, which was 93.6. And divide that by our original and times by 100. And what's so wonderful about the calculators that you guys have got is that you can actually do this straight on your calculator. So let's clear that. Right, we've got our calculator, write it as a fraction. It's 96.3 minus 93.6 divided by 93.6. Always check as you're typing on your calculator that you're actually typing in what you want to be typing in. Because there's nothing worse. India, I don't know how often you've experienced it, but they see it on the calculator and they know, but it must be true because the calculator said so. So
that's something I would do.
It's very frustrating.
Never trust your calculator 100%. Mine said
Well,
is.
You can trust your calculator 100% if you're checking as you're entering the numbers.
That's true.
And you're entering the numbers
correctly. Check and recheck. That's all I'm saying. Double check.
Okay, so we got 96.3 minus 93.6 divided by 93.6, and then we're going to times that by 100 because it's a percentage, and we get the answer of 2.88%. We're going to round to 2 decimal places because I didn't write that as a 2.88%. I'm going to round to 2 decimal places because it hasn't said otherwise. Well, I'm going to double check the question. It just says calculate the percentage increase in enrollment. Okay, 2 decimal places because your exams usually say 2 decimal places. So if there's no instruction otherwise, then go with 2 decimal places. And remember, that's a percentage and it's an increase. Whenever you do this calculation that I showed you earlier, this one here, if you get a negative answer, just be aware that you cannot have a negative percentage. It doesn't make sense because percentage is something out of 100. So you can't have minus percentage. But what it means is that you have a percentage decrease. So it has gone down, and that is why there's the negative. So we take away the negative, and so let's just, on the side, take it if we end up with an answer of, say, minus 12.3. We cannot have minus 12.3%. It doesn't make sense. We delete that and we say that is a decrease. Okay, so just on the side, but I guess we don't need to know that because that's not part of our question now. And let's move on to the next part of this question. And the question now says, we've still got our table. Use the graph. Okay, which age group had the largest percentage enrollment during 96? So this would probably be easier to look at the graph. We want the largest percentage enrollment. And what you could actually do is you could take your ruler. I wonder if this will work. I'm going to try this. you could take a ruler and kind of draw a line across. Okay, we'll take your ruler and place it at the top of your graph, and then you can actually just pull this down. So we're looking for 96, which is the highest in 96. No, that went down too far. Highest in 96 clearly is the 13-year-olds. But then we could have also just looked at our numbers and seen that our 13-year-olds was the highest in 96. So there are a number of different ways that you can answer the question. So this was our 13-year-olds. Okay, and the next question says, the greatest increase in percentage enrollment between 96 and 2007. So now for our percentage increase, we need to look at the difference between the two. We can possibly see this on the graph. Now we can see on our graph the difference between those two. Okay, let's move that away now. The difference between those two is very little, and we look at our 12-year-olds, very little, and it's kind of getting bigger as we're going along. So possibly we need to compare those two values. Okay, and now it will be easier for us to actually look at the table. So now we're looking at the difference between 73 to 94, which is about 20, and 81 to 95, which is about 15. So I'm just rounding off just to get an idea. Now, if I had values that were closer, then I would actually have to do the calculation. And what would I actually do is I would say, well, okay, I'm at 2001 minus my 1996. So I would actually do the calculation, but I think quite safely I can say it is our 7-year-olds, and it's not 2001, it's 2007. Right, so this is 7-year-olds. And the next question, we've got the greatest increase. Oh, there was this. Sorry, I was reading this one for some bizarre reason. Okay, make that a 7. The greatest increase in percentage enrollment. I left out this question. The smallest percentage enrollment during 2007. So now we're looking at the smallest, 2007. So again, I'm going to take my table. I'm looking at 2007, which is a grey, and I want my lowest value. And my lowest value was my 7-year-olds. And if I look at the values, I'll see that it is my 7-year-olds. So the smallest was 7-year-olds. I think I jumped the gun there and did the questions kind of like out of order. But that happens. So that's where it's important, guys, to actually go back and reread the question and make sure that you've actually answered what they're asking and I didn't put the answer in the wrong place. So we've got the largest percentage enrollment, we've got the smallest percentage enrollment, and we've got the greatest increase in percentage enrollment between the 2 years. Let's see what else they want us to know about this question. If there were 240,000 10-year-old children in South Africa in 1996, calculate the number of 10-year-old children enrolled in primary school. So we want the number of children. So there were 240,000 grade 10-year-olds. And we want to know how many of them were enrolled in 96. So we need the value in 96 of 10-year-olds, and that was 91.3%. So we're going to times this answer by 91.3%. So get our calculator out. Okay. Get our calculator out. Try that again. I've got 240,000 grade 10-year-olds, I keep saying grade 10, times by 91.3%, and we get 219,120. $219,920. Just want to double check that that is the right number. 219,120. Indy, isn't that sad that there were about 20,000 10-year-olds that weren't enrolled in a primary school?
That's terrible.
Well, if we look at it the other way, it's actually that there were close to 9% of our 10-year-olds that weren't enrolled in 1996. Glad to see that it actually is improving.
Yes, yeah.
It really is nice to see that. But it is quite sad. have we answered the question? The question says calculate the number of 10-year-old children enrolled in primary school, and we've got a number. Now remember, in this case, guys, you're going to need to have a whole number. We were lucky, it worked out perfectly, but if it became a fraction, you need to round off to a whole number, because we're talking about children, and we're talking about children enrolled in school. So it would have had to be a whole number. So let's see what our next question. Right, we're moving on to the next question. So we now have question 5. Have we got enough time, Indy? I think we've got enough time to start it. Below is a graph which indicates the average rainfall for 2 cities in South Africa. All the figures indicated have been rounded to the nearest 10 millimeter. So all the figures have been rounded. Right, which means that we're ending up with very clear, nice numbers. Very easy numbers because they've been rounded to the nearest 10. So we've got our average rainfall, and we've got City 1 and City 2, our average rainfall in millimeters. And we've got the months of the year from January through to December. So what do we notice is that City 1 has got very little rain in January, whereas City 2 has a lot of rain. And City 1, if you look at City 1, it is constantly increasing to about July and then decreasing again through to December. That's City 1. And City 2 starts at a high and decreases through to July, where there's no rain at all, and increases again November, a little bit down in December. So we've got 2 total extremes. And I think that's probably a clue for one of our questions that we need to answer. Right, let's go through to the questions. Do you think these 2 cities are close to each other? Give a reason for your answer. So going back to our graph. Now, if we think about cities that are close to each other, we tend to have the same kind of weather. Am I right? Like if we just take Joburg and Pretoria, you know, it tends to rain in Joburg kind of in our summer months. So January, Joburg and Pretoria tends to rain at the same time. So they're close to each other. We tend to have the same, not the exact same, because I mean we can have days where it rains in Joburg and it doesn't rain in Pretoria, but more or less the seasonal rains would be pretty much the same. Our temperatures are very similar. No, Joburg and Pretoria, we normally just a few degrees. Joburg's normally just a few degrees smaller than lower than Pretoria. Whereas if we had to look at like Joburg and maybe Durban, we would have 2 totally different weathers, or Durban and Cape Town. So in this particular example, we've got city there where it rains, and now we think about this is in South Africa. So if we're looking at our months, I want to actually add to this that January, February, we've got summer. Then we've got, okay, we won't worry about autumn. Then here we've got winter. And then we're back here to the end of the year where we're in summer. Because while we're in the southern hemisphere, and those are our seasons. So we've got one city where we've got summer rain, that's city number 2, and very little rain in winter. And the other city that is winter rain and very little in the summer. So are they close to each other? I would say no. In fact, I'm probably taking a flyer that they're talking about Joburg and Cape Town, where Joburg we have summer rain, or even Pretoria and Cape Town. So our answer, do you think these 2 cities are close to each other? I'm going to go with no, and then give reason for your answer. I'm going to actually say, well, City 1, it rains in summer. Was it raining in summer or winter? City 1, it rains in winter. Rains in winter. And City 2, it rains in summer. And I think on that note, with all this rain and summer and winter, I think maybe we should take a little bit of a break.
Yeah, okay, so what we're going to do, guys, we're going to take a little break. Njabulo said a quote for both matrics and grade 11s that I got from the internet. At one point in your life, you will either have things you want or the reasons you don't. Good luck on your prelim, guys, and that's what an awesome message. And what we're going to be doing, post all your questions, and we'll see you now after the break. Hi guys and welcome back. We are going into the last 10 minutes of the grade 11 show. I can't believe how fast it's gone. So if you do have any questions, please post them now. Marcia, we do have your question lined up, so it is coming up. So keep your eyes peeled. Haley,
Thanks,
take it
Indy.
away.
Okay, let's see if we can finish this and then we will get to the other questions. So I'm going to calculate the range of rainfall for City 1 over the 12-month period. So remember, my range is my highest minus my lowest. So let's go back to my table. And City 1 is my blue. So I'm going to actually draw a line across my right to get the highest for City 1. Remember, that was my blue. So there's my highest, okay? So that's 110. And my lowest for City 1 was December, which was 10 centimeters. So my range, let's get to the next question. For City 1 was 110 millimeters minus my 10 millimeters, and that was 100 millimeters. So that's my range. Calculate the mean rainfall for City 1 over the summer months. That's November, December, and January. Round off your answer to 2 decimal places. So my mean, and I just want it over those 3 months. So I've got November, December, and January for City 1. So let's go back to my graph. City 1. City 1 was my blue. I need November, December, and January. So I've got 20 plus 20 plus 10. Because remember, they were all rounded to a whole number. So I've got 20 plus 20 plus 10. That was, I don't remember where the 10 was. Yeah, it was December. Okay, so we've got a total of 50, and we're looking at our mean. So divide that by 3, and it said round to 2 decimal places. Now, get my calculator out. So 50 divided by 3, 16,67. So 16,67. And remember, these were millimeters. So we continue to use millimeters. Determine the mode of the rainfall for City 2 for the year. So the mode, we're looking for the month where it rained the same. So let's go back, and we're looking at City 2 this time. So City 2 is my white one, and I'm going to use my ruler again. Right, I've lost my ruler. Okay, I've got 2 cities that are at 120. Let me check if I've got any others that are exactly the same. I've got 2 that are at 80. This is really not cooperating with me, Indy. I've got 2 that are 80, and let me see if I've got any more that are the same. We're looking at our white. Those aren't the same. So it looks like we've got 2, and we've got 2 at 10. So in actual fact, I've got 3 months where I've got the same amount. I don't have one where it stands out as, okay, I don't have one where we've got the same number. So we're looking at our modal. Okay, I'm struggling to move this. So I'm looking for either where we've got 3 months, but I've got 2 months, which are the same. So in actual fact, my answer is going to be, well, okay, January and November. And then the next one would be, okay, March and October. Those are the same. And finally, June and August. So my actual answer is a little bit more complicated than just giving 1 month. Calculate, determine the mode for the rainfall for City 2 for the year. So my mode is, in actual fact, it was the 120 and the 80. I think it was 80 and the 10. And just go back and double check that that was 80. So that was 80 and the 10. So I've got 3 modes. Now remember, that's possible. We can have more than 1 mode, and we can also have no mode, and that can be an answer. So if you got no mode, still a valid answer. Let's see what our next question says. Right. Determine the median rainfall for City 2 for the year. Right, well, now we're going to have to put these all into order and determine the middle value. So let's go back to our calculation. Indy, you're going to have to keep looking for City 2, and I need you to keep hold of these values. So City 2 is our white one. We've got 120, 100, 80, 50, 20, 10, 0. Important that there's nothing in July. 10, 40, 80, 120, and 110. Have we got all those values?
Got it. City
Okay.
2.
City 2. So let's put our thing. So most important thing to note about this is that in July we had no rainfall, but it still counts as a month. So we have to actually have, so okay, let's give me those values back. So we had
120,
120,
100,
100,
80,
80,
50,
50,
20,
20,
10,
10,
0,
0,
10,
10,
40,
40,
80,
80,
120,
120,
and 110.
and 110. Okay, so I think that it's quite easy for us to put these into order. So we've got, I'm going to start with our highest. We've got 120, 120. So those accounts for those two. Then I've got 110. Okay, and then I've got two 80s. I've got, I've got 100. Let's move our 80s. No, it's not going to move my 80s across. Okay, I've got 100, 80, 80, and carry on. 80, 80, then I had 50, 40, 20, 10, 10, and 0. Now double check, I've got 12. 2, 4, 6, 8, 10, 12 months. So I've got the entire year. Now I'm looking for the median. That's my value between my 2 in the middle. So I'm going to count 6. 1, 2, 3, 4, 5, 6. And my median is actually between 80 and 50. So on my calculator, I'm going to say, well, 80 plus 50 and divided by 2. And my value is 65. So the median in this case was 65. Let's use a different color. Was 65. Right. Is it realistic that City 2 actually made 0 millimeters of rain in July? Is it realistic? Well, what we have to look at in this case is our context. Could they have had no rain? Probably not, because they had rain in June and they had rain in August, so probably not. But remember at our beginning, we rounded off to the nearest, we rounded to the nearest 10. So if we rounded to the nearest 10, then they could have had as much as 4 millimeters of rain, and we would have rounded that off to 0 millimeters. Rounded that off to 0 millimeters. Okay, so is it realistic? Probably not, and they probably did have some rain. I think that answers the rest of the questions, but now there was a child who wanted to know, what was her name, Indy?
This one was from Musa. Let me just
Musa.
have a look. Do you want me to read it out for you?
Okay, read it out. I think she wanted to know about interquartile range.
Yeah. She said, can you please explain what an interquartile range is?
Okay, so interquartile range, Musa, right, what we have is when we have values, we start off, if we place our values in order, let's start off with our smallest value. We've got our minimum value. And our biggest number will be our maximum number. Okay, so we've got my minimum, and that's how I would get my range from my min minus my small. Okay, so if these were all values. In the middle of this table, I have my median. That's my middle value. The middle of my lower half, I actually have my Q1. That is my quartile 1. And the middle of my top, I have Q3. So what I've basically done, if I take a different color, is I have divided all my values into quarters. 25% there, 25% there, 25 there, and finally 25 at the end. Okay, so I've divided it into 4. My interquartile range takes the value between Q3 and Q1 and gives me 50% of the values that are closest to the median. And the reason we use that is it excludes outliers, both small and big. So it gives you your range of 50 values closest to your median. And interquartile range is actually, your interquartile range is actually Q3 minus Q1. I hope that actually helped, Indy, and I don't know if I've got any more time to carry on explaining this, but I feel like I'm running out of time. I think I'm running out of time. I'm going to say goodbye to everybody because I'm going to hand over to Indy, who's going to end off the show.
I can't believe how fast this show has gone, guys. Grade 11s, I hope that you had an awesome time. If there is anything that you are still wondering, please post it on the page, and either we will help you out on the page or another mindset will help you out on the page. This community is for all of us. It's for you guys to learn more and to learn extra. Grade 12s, you're next, and prelims are coming up, so let's make sure that we are tuning in so we can really, really do well at those. Grade 11s, you've been so awesome. Just in case you did miss the answer for the squares, we posted a picture on Facebook that said how many squares are in the picture, and the answer is 40. True story. Go and have another little count. Thank you so much, guys, for an awesome show. See you same time, same place next week. Bye.